Welcome, my dear students. Today's lecture is concerned with how to implement the Cohen-Sutherland line clipping algorithm. So in this lecture, we will solve certain problems or effectively implement the Cohen-Sutherland line clipping algorithm on certain window. So before starting with this with certain numericals based on Cohen-Sutherland line clipping algorithm, let's revisit the idea of what was Cohen-Sutherland line clipping algorithm. It follows four-step procedure. First step was that simply that we assign the outcodes or 4-bit codes to the endpoints of a line. Okay, fine. So in this second point is we perform OR operation between two outcodes bitwise. We will perform OR operation bitwise between two outcodes and check whether the result is 0 or not. If it is 0, then it simply allows you to trivially accept that line, trivially accept it. So in that case, simply we will accept that line, means it gives you the idea that the line is completely lying within the visible region and it is completely accepted. So clipping is not taking place across the edges. Okay, now the third point is then we perform if it is not so, if it cannot be trivially accepted, let's say, then we will go with the perform AND operation, and every perform AND operation between the two outcodes of a line. Then if it gives you the result non-zero value means we can trivially reject, that is the line is completely lying outside the visible region, somewhere here. Okay, like this. So this is the case. If this fails, means a line is not completely lying outside the visible region or not completely lying inside the visible region, then again fourth step, that is perform AND operation, and if it AND operation between the two outcodes, outcode 1, outcode 2. Okay, and if it gives you the result as 0, all 4 bits become 0, means clipping is required. And when clipping is required, we have to calculate the intersection points. Okay, intersection points we have to calculate across the edges. For example, if this is the line, then these intersection points has to be calculated. Okay, so this was basically the Cohen-Sutherland line clipping algorithm. Once these steps are over, then we again re-execute the algorithm for the remaining line we are left with after applying these 4 steps on a part of a line. So let's see how this will be implemented on the real problems. Okay. So this is first I'll explain it what is. Don't get confused with all that writing that is made available on the site. That is very easy to understand. So first thing, that this is the question, that is implement the line clipping algorithm for the line P naught. This endpoint is, one point is given, first point, and the endpoint is given 70-90, and the window size is 60-40. That is X min, Y min, and X max and Y max. Okay, so you can visualize the figure. The points are placed, and the region is outcoded. So you know that in a Cohen-Sutherland line clipping algorithm, the region is there are 9 regions, and each region is given with the 4-bit code. Okay, so this is the boundary conditions for the rectangle or the window size or the viewport. You can say 60-40 and the 170. A line is drawn from P naught to P end. Okay, and the P naught points are given 30-65, and P end is given 70-90. So by looking at this, that is, this X is less than X min. So this point is lying on the left hand side. So this bit will be 1. Okay, so that is why the code is assigned. Likewise, if we talk about the 65, that is Y. Okay, so this is giving you the idea that this code is 001. So it will be P naught will be outcoded with this code. Likewise, when we talk about P end, so here you can see that this outcode, it is lying between X min and X max, but it is moving above to the Y. Okay, so Y value is, it is above the Y max. Okay, so this bit is on, that is A, B, R, L. Okay, so this bit is on. So in this manner, these endpoints are outcoded. Okay, fine. So the outcode for P naught is this, and outcode for P end is this. Fine. Now what we will do, we will go with the algorithm. First, the outcodes are assigned. Second point is perform the AND operation, to perform the OR operation to see whether this line is completely within the visible region or not. So let's perform the OR operation between this 1 0 0 0 and 0 0 0 1. If I perform the OR operation and it yields 1 0 0 and 1, so it is a non-zero value. Okay, means simply it is not 0, means we cannot trivially accept this line, means complete line does not lie within the visible region. Okay, so we will follow the third step, that is perform the AND operation between the two endpoints. Okay, so third step, perform AND operation. So this is the third step. That is the third step. So output for P naught is 0. This, so AND operation perform, that yields 0. If it has given the result non-zero value, then we can say that line is completely residing outside the visible region. Okay, but in this case, when we have followed the procedure of Cohen-Sutherland clipping algorithm, we have got the resultant after applying the AND operation between these. So don't go with the visibility of the line. Okay, कि that it is lying outside. ये मत देखिए कि इससे बाहर जा रही है तो हमें इसको क्लिप नहीं करना है. we have to follow the procedure of the line clipping algorithm. So first step we have followed, second step we have followed. So in second step, it is not giving us the non-zero value. If it has given the non-zero value, we can trivially reject the line, but it is resulting in all zeros. When it is all zeros, means clipping is required. When we perform AND operation and it results in zero value, then clipping is required. Okay, so against the top edge, so we are taking this P naught. Okay, so clipping will be required against the top edge. Okay, so we are moving from P naught to P end. Okay, so we have to calculate this point P naught dash, that is the new point. Okay, that has to be calculated. So this is the intersection point that has to be calculated against that edge. Okay, so see how we are going to calculate. Now first we will, to calculate the intersection point, first we will calculate the slope of this line. So slope of this line says y2 minus y1 is divided by x2 minus s1. That is why 90 minus 65 and 70 minus 30, that gives to 5 by 4. So that this is the slope of the line. Okay, now I know that if you can see within the figure, the y max, it is y min and it is y max. And what is the value of y max? That is 70. Okay, so here at this point, what you know, that you are not known with the x. If I'll draw a line, so x will be varying. If I draw any line across this edge, let's say this, okay, so you can see the x is varying and y will remain same. Okay, so here I have to calculate the x value and y value will be the y max simply. So in this manner we are going to calculate the intersection. So we know the slope. So if I want to write the slope of this point, so how can I write? So I am writing it as a x, okay, and I am writing it as a y max. Okay, and this is your x1 and y1. Okay, so let's say this is x1 and y1. So how I will write the slope of it? That is m is equal to y max minus y1 upon, okay, then x minus x1. Okay, and I have to calculate this point x. So how can I do that? Simply I can bring m below to this, x minus x1 is equal to y max minus y1 upon m, and x will be equal to x1 plus this term y max minus y1 upon m. And m, we know that the slope of a line will remain same throughout for this line. So m by m is equal to 5 by 4. So simply that at the top edge y max is known, we have the calculated x for p naught. So x is equal to x1 plus y max minus y1 upon m. Putting the values, x1 we know, against this top edge we are just, so this will be treated as x1. So this will be x1, x1 is 30. Okay, x1 is 30. Now y max is 70. y1 is 65, okay, and slope is 4 by 5 by 4, so it is reciprocated by, that is 4 by 5. So when we do the calculation, you will get 34. So value of x is 34 over here. And what is the y value? That is 70. So p naught dash has become 3470. Okay, so let's clear the drawing. All right, now we have got, that is p naught, this point, and this point will be, this part will be discarded because we have calculated this intersection point, means this part is lying outside the visible region. So you are left with p naught dash 3470 and p end is 100. So p end is 7090, and the output for this is 1001, and the output for this is this. Okay, so here you can see that it is lying on the y max. Okay, y max value, y value is equal to the y max, and x is lying below to the 60. Okay, so means it is on the intersection of left and top. Is it clear? So it is on the intersection of left and top, so we can easily assign by checking the condition whether x is less than x min or a greater than x max. Likewise, we can check for the above part whether it is y is less than y max or it is greater than or it is below the y max. So you can see this outcode will be provided to this point likewise. Okay, so now we are left with this line. Okay, again we will re-execute the algorithm from the top, that is from the first part, that is the codes are assigned. Okay, second part, we will perform the OR operation between the two AND codes. OR operation, if it is giving the 0, so it is visible region, so it is not, so it cannot be trivially accepted. Third part, AND operation, if it gives non-zero value, then it should be trivially rejected. Let's apply. So again executing p naught dash, third operation perform कर रहे हैं हम, AND operation perform किया हमने, तो p naught dash की वैल्यू क्या है 1001. okay, and p and की वैल्यू क्या है 100. okay, so we have assigned the code. थर्ड पॉइंट, थर्ड फेज का, थर्ड स्टेप का काम कर रहे हैं, तो एंड ऑपरेशन परफॉर्म किया और इसने क्या दिया हमें, नॉन जीरो वैल्यू. जब नॉन जीरो वैल्यू आ गई तो इसका मतलब क्या हुआ, ये जो लाइन है कंप्लीटली आपकी विजिबल रीजन के बाहर लाई कर रही है, सो कंप्लीट लाइन विल बी discarded. So we will not go with the fourth step. Reason being because our purpose has solved at the third step. The complete line is discarded, so it is, so complete line is rejected, so algorithm terminates here. So in this manner the complete algorithm will work, and so we will calculate the value of intersection in the first case. Okay, so we have not directly rejected the line by looking at the figure only, but you can see we have to apply the procedure, and after applying the procedure we have to check each and every condition to see whether the line is completely rejected, completely accepted, or the clipping has to be done across certain edge. So this is one problem that I have explained you. Let's go for the other cases very quickly. Okay, so here you can see that the two endpoints are given, p naught and p end. The output for p naught is all zeros, p end is all zeros. Okay, so you can see this x and y is lying within the x min and y min range, and this is also lying within the x min and y min range. Okay, so we can simply perform the operations. So first operation is OR operation perform करेंगे हम. जब हमने OR operation perform किया, in first step only we will find that in the first step of the algorithm only we will find that the resultant of all operation OR operation is 0, so it will allow to trivially accept the line, and algorithm terminates there only, वहीं के वहीं आपकी terminate हो जाती है. So simply after first step only we can identify that the line is completely visible and within the viewable region. Likewise, the same question is taken with another same window is taken with another line. So it is given with 30, 45 and 5080. We will assign a code. Codes are assigned and outcodes are assigned to the endpoint. Second point is to perform the OR operation between the two endpoints. जब हम OR operation perform करेंगे तो क्या होगा इसमें OR operation perform करेंगे तो हमें क्या मिलेगी नॉन जीरो वैल्यू 1001 and 0001. Okay, so it is non-zero value. Okay, or operation में so means it cannot be trivially accepted. Second operation क्या है हमारा ये trivially accept की condition है. ये फिर हम AND operation परफॉर्म करेंगे. AND operation में अगर हमें ये non-zero value मिलती है तो AND operation परफॉर्म करते हैं 10 it is written over here 1001 and 001 AND operation is performed. It leads to non-zero value. So in third step it gives you the idea that is the line is lying completely outside the visible region. That is why this is the condition for the trivially reject of a line. So we reject the line completely over here and algorithm terminates there only. So we don't have to calculate any intersection point in this case because the clipping is not done. Simply by looking at the outputs only we have come to know that it is trivially accepted or trivially rejected. Now going with another problem, okay, that helps you to understand better this concept. Okay, so let's solve this problem. Okay, so the line is given endpoint 3020, okay, and 9080. Okay, so this is the same case that we have done with this. So in this case also we have done the clipping, but in this case the line was clipped and in the second attempt the line was completely rejected, but the clipping was performed. Okay, but in this case again we have to do the clipping. Let's do it. Okay, so first assign the outcode. The codes are assigned 0 1 0 1 and 1 0 0 0. How the outcodes are assigned? By checking out the inequalities of x min and x max with the x and y. Likewise x2 and y2 with the x max and y max. So by checking out the inequalities, that is lying below to the x min and as well as y min, so this point will lie over here in this intersection. So outcode is provided to it. Okay, so the outcode is assigned. Now we will perform the operation. OR operation is performed. So let's perform the OR operation will result in non-zero value. You can check it simply. So first step is over. Okay, means line cannot be trivially accepted, means the line does not lie within this visible region. Okay, now second step, perform the AND operation. Now when we perform AND operation, it gives us the zero value and again zero value and again zero value, means it cannot be trivially rejected, means clipping is required in this case. So when the clipping is required, so across this edge the clipping, because we have taken this p naught, so across this edge the clipping will be required. Okay, now let's say this is the value of what we have to calculate here. We have to calculate the x value. Okay, x value we have to calculate, and what we are known with it for this point is the y min. We know the y min over here. Okay, y min we are not to it. How the intersection will be calculated now? I told you previously. Intersection कैसे calculate करेंगे? Okay, that you have to calculate the slope, and what will be the slope? that will be y2 minus y1, that is complete line slope, that is y2 minus y1, and x2 minus x1, that will give you 80 minus 20, 80 minus 20, and it will give 90 minus 30. Okay, that will lead to 60 upon 60, that is equal to 1. Okay, so here the m is value is equal to 1. I'm just erasing it now and I'm writing directly the value of m over here. M has come 1 of this line. Okay, now what is m for this line? The remaining part, that is m is equal to, m will be equal to x minus, sorry, that is y min minus, that is, let's say it is y1. Okay, this point is y1, and we are having x minus x1. Now you know the slope. X y min value is what? Now let's calculate the value of x in terms of m. X will be equal to x1 plus y min minus y1 upon m. Okay, I think it is clear to you how we have come across. So m is brought here, the complete expression is taken up to the left hand side, then x1 is placed here. So you can easily come across this. Now putting the values of x1 is what? That is 30. Okay, plus y min is what? Y min is 40 minus y1 is what? 20, and divided by m, sorry, and that is 1, m is 1. So we have got the value of x, we have got the 50. 40 minus 10, it is 20, and 50. 50, that is the value of x for p naught dash. The value of x is 50, and what is the value of y? That is y min. Y min is 40. Okay, so we have got p naught dash point as 50, 40. Okay, so now in this I in the disadvantages, I told you that it follows the fixed order. Okay, now we have to follow the cyclic order to do the clipping. Now we will not go with the p naught and p end. We will not take the line p naught dash and p end. Now we will follow the line p end to p naught dash. Okay, to calculate this intersection. Okay, so means every end should not monopolize the line clipping algorithm. That is why once across the one of the edge it is done, then we will go with the cyclic order. We will see whether any clipping has to be done across this edge or across this edge. Then we will come back to the endpoint once again. So now we have calculated it. Now if I draw it, I'll get this structure somewhere. Okay, so this line is clipped, this line is clipped. Okay, and we are left with this. So I think okay, fine. So Let's take this line now, P and P naught dash. Okay, again the outcodes will be set, algorithm will run. First step, outcode देखिए इसके. So outcode is 0 0 1 and 1 0 0. Okay, now perform the OR operation, then perform the AND operation. Okay, first is OR operation. It is not completely inside the visible region, completely cannot be rejected. Now means clipping has to be done across this edge, because we are taking P naught and as this point. Okay, so across this edge this clipping has to be performed. Now we have to calculate the P and dash. Okay, in this P and dash, what we have to calculate is the X parameter. We have to calculate the X. Okay, and what is given is Y max. Y max is given. Okay, so for this part, this will be the X1 and this will be the Y1. Okay, let's do the intersection. For this we have to calculate the value of X. X will be equal to X1. X will be equal to the X1 plus Y max minus Y1 again, and then M. Okay, slope of that line. So simply the same formula, but it will be replaced with Y max. I hope you are now able to understand how the intersection points are calculated. So in this we are finding out the value of X, because whenever the line will be cut across this edge, X will be varying and Y will remain same. Okay, and what Y will remain same? Y max. So the complete slope of a line is given M, we know it, and the slope of this line will be, that will be X. Your Y1 slope of line, there will be Y max minus Y1 and X1 plus Y max. Okay, so what will be the value for this case? X1 is X1 is 90 plus Y max is 70 minus, and Y1 is 80. M, that is 1. That will lead to 80. Okay, that will lead to 80. So the point P and dash will be your 80 70. Okay, so this point will be 80 70. Okay, so let's redraw the figure. We are left with what? We are left with this. Because this will be clipped after applying this part. So we are left with P and dash and P naught dash. And what are the points? P naught is 50 40, and p n dash is 80 70. Okay, now we will apply, then now we will come through the cyclic order. We will see across this edge if there is any line, no, then we will come across this line, no, then we will come across this point, that is p not dash. Now again we will follow the rule, assign the outcode. Outcode for this would be 001. You know how to assign the outcode. And what will be the outcode for this? Because it is line within the visible region, it will be 0 0 0. Okay, so this will be the point. Fine. Now we will perform first, assign the code is done. Now second step will be performed, that is OR operation. OR operation will lead to the non-zero value, means the complete line is not in the visible region, so it cannot be trivially accepted, as well as it cannot be trivially rejected, because AND operation is not giving the non-zero value. AND operation. Okay, now you can see the, you can write the outcode for it, that is the p naught dash का output क्या है, 0 0 0 1, and the pn dash का output क्या है, 0 0 0 and all zeros. Okay, now when we perform the AND operation, it will give us, that will give us 0 0 0 0. If it would have given the non-zero value, means we can trivially reject the line, but the clipping has to be performed. Now the clipping has to be performed across this edge, that is, that will be the new point, that is p naught double dash. Okay, and what we have to calculate here, that we are known with the x min value. We know the x min value. X min value is your 60. We know that x min is 60, but what we have to calculate is y. We have to calculate y. Okay, so how we will calculate the intersection points? How we will calculate the intersection points? Let's calculate it. Okay, so we'll take up these new endpoints to calculate the p naught double dash, because we have already clipped the line one after another, executing the algorithm step by step. Okay, so we know that the slope of the complete line is m is equal to 1. We have already calculated it. Okay, now for this slope, for this endpoint, what will be the slope? That is m is equal to, if I write the formula, that is, okay, so we will consider this as a x1, this as a y1. Okay, so m is equal to, that is y minus y1 divided by x min minus x1. Okay, so we have to calculate the value of y. Okay, so if I rewrite the formula, y will be equal to y1 plus m into x min minus x1. And what is the value of y1? y1 is 50, m is 1, and x min is 60. And what is x1? That is 40. Okay. Now you can y is equal to, okay, I think I have kept the wrong points over here. I have kept wrong points. Okay. Y1 is 40. Okay. And plus m is 1. Okay. And x min is 40 over here, not 60. Okay, point wrong over here. X min is 40. Okay. And then x1 is 50. X1 is 50. Fine. Now it is correct. Now what will be the value? That will yields to 40 minus 10, that is 30. Okay. So this P naught dash will be, that will be, I think some mistake is done over here. You have the P naught dash is we have received as 50 40, correct? And what will be this point? That is 60 40 is the x min and y min. So this will be 60, not 40. This will be 60. So let's erase it. Okay. So this point will be P naught double dash will be, we know the x min value and we are going to calculate the y value from here. Okay. Now let's see what is happening. Y1, let's erase it once again. Okay. Let's put these values. Y1 is 50. Y1 is 40, sorry. Y1 is 40 plus m is 1, x min is 60, okay, minus x1 is your 50. Okay, so 40 plus 10, that will give you the 50. That's correct. Okay, 50. So now the P naught double dash will become 60 comma 50. Okay, so after this you will get this line. Okay, and this will be P n dash and this will be P naught double dash. Now after this also we will execute the Cohen-Sutherland line clipping algorithm. So the endpoint of P naught is lying within the visible region. The output will be all zeros and the output of this endpoint will also be all zeros, and then we will perform the second step, that is OR operation between the endpoints, and it will give us all zeros value, so it can be trivially accepted. So these will be the steps to clip this line across this window size. Fine. So I think I should show you another problem, and I hope that you would be able to do it on your own. Okay, so clear all my drawings. Now this is the another question that I am leaving on your side, that you are going to solve this problem or you are going to implement it using Cohen-Sutherland line clipping algorithm. I hope the lecture was understandable to you. Thank you all. Welcome, dear students. So I have given you certain problem to solve as an assignment, and many of you have solved and submitted it. So let's take up that problem. Many of you have done certain mistake. Okay, so I will not explain the algorithm, that you know that the size of the window is given 60/40 and 170. So this is x max, y max. Okay, this is x max. Okay, and this is x min, and this is y min. Okay, so by applying this you will perform OR operation. Means when you will perform OR operation, it cannot be completely acceptable, and if you perform AND operation, it gives doesn't give you the it doesn't give you the non-zero value, so it is not completely rejected. So when we perform AND operation, it will give you the all zeros values. So we will do the intersection. So P naught is this, so we will find the intersection point here. Okay, so we will calculate the slope. M is calculated. Okay, so that comes y2 minus y1, x2 minus x1, that is minus 60 minus 20. Okay, divided by 110 minus 80, 110 minus 80. Okay, that leads to 4 by 3. Okay, so that leads to 4 by 3. So this is the slope of this line. Now what do we have to calculate over here? That we have to calculate the value of x. Okay, and we know the y, that is here it is y min. Okay, that is y min, we know that is your 40. We know that it is 40, but what is varying here is x, so we have to calculate the value of x. Okay, so this will be treated as x1 in this case, and this will be treated as y1. Okay, so formula for this is simply we'll calculate the x value. Okay, so x value, that will be your y x1. Okay, plus m plus y min minus y1 divided by m. So x1 you know that is your 80, x1 is 80, plus y min is 40 minus y1 is 20 and divided by 4 by 3. That will become 3 by 4. That will simply, let's write over here 4 by 3. So after calculating, you will get 95. Okay, so this will be the value of x. So what will be the value of this point, intersection point? That is, let's say we call it as a p naught dash, then this value will be given by, that is x value has arrived as 95. We have calculated it, and y min we know because it is lying on this edge. So across this edge it is clipped. So y min is 40. Okay, so this point, this line will be clipped, and you are remaining with this point P0. Now after this, most of you have done mistake over here only. When you are calculating this intersection point, what you have to find out, that is y, because y is varying, okay, across this edge y will vary. And what will be the value of x in this case? That is x max. Okay, x max is, you know, that is 100. Okay, so x max is 100. Fine. So this value you have to calculate over here. And what is the p end is 110 and 60, so this will be treated as x1 with respect to this edge, and this will be treated as y1. So formula you know for this, that is y, you have to calculate the value of y, that will be equal to y1 plus, okay, slope m and x max minus x1. Okay, fine. So y minus y1, y minus y1. Okay, so this is the first point. In this case, this is the second point. Okay, and how we calculate second point minus your first point? In the same case here arises, this is the your first point and this is your second point. Okay, so the slope will be calculated like y min minus y1, likewise x1 x minus x1, that will be slope. Likewise, this will be treated as the first point and this will be treated as the second point. So how we have come across with this? So first point is this, second point is this, so we will be writing is as y minus y1, okay, and your x max minus x1. Okay, that will be equal to slope. From here we have calculated the value of y. Okay, so this formula has come across from this equation. And how we have come across with this equation? So by subtracting it. So we know the value of m and we know the value of y1. So what is the value of y1 here? That is 60. y1 is 60. Okay, and m is 4 by 3, and x max is, what is x max? 100 minus x1 is 110. So you have mistaken here, actually you have taken 95 at this point, most of you. Okay, so 110, so you will calculate the point, you will come across 46.66, I think. Okay, then you can make it as a 47. Okay, so this intersection point will come as p and dash, that will be your 47, will come. Okay, okay, so this is the value of x max. So order has got changed here. So x, if I write in terms of x max minus comma y, so we write in terms of xy. So I have written in the reverse order. So this is the value of y, this is the value of x max. So in terms of xy, if I write x is 100, x max is 100, okay, and your p n dash will be 100 comma 57. Okay, so in this manner you are going to solve this problem. So I hope you are able to understand. Okay, so let's move to another topic.